Okay, so welcome back. This is part 8 in our series where we show you how to program your test instruments, your bench instruments. And we're using Visual Studio. You can use any software or environment you want. And in previous videos in this series, we showed you how to develop this application you see here, which we're doing in Visual Studio. And we started out in this series showing you how to build this application where you can do a frequency response analysis on whatever circuit you have. We showed how to do it on a transformer winding to determine if the winding is good. You can also use it on filter circuits, any type of electronic circuit or electrical circuit you want to apply it to see how the circuit responds to various frequencies. So I encourage you to look at those previous videos in the series, and I've got a bunch of other videos. I got over 250 videos on this channel. Now what you see here is this application with the additional functionality we added in the previous video, where you can grab a waveform from the oscilloscope. You can see I've got my bench oscilloscope with a signal generator, and the scope is measuring two channels coming out of the signal generator. One is a square wave and one is a sine wave. And we showed in the previous video how we can grab a waveform from the scope, as you see here. And what we're going to do in future videos is show how you can not only grab one waveform from one channel, but you can grab multiple channels. You can see I can jump between sine wave and square wave on channel 1 and channel 2. And also in a future video, we're going to show you how you can do what we're doing here, which is updating the capture of the waveform, in our case every 0.2 of a second, and I can select between which channel. And we're also going to show you in the future how to do multiple channels. We're going to display, as you see on the scope, we're going to display multiple channels on our chart here. So I encourage you to look at the previous videos and hang around for the future videos. Now in this video, we're going to take the next step from our previous video where we showed you how to write the additional software in this application to grab a waveform. And in that video, we noted that each waveform that we grab from the scope has what's called a header. Now, a header is something you're going to see in just about every electrical, electronics, communication, data acquisition project that you work on. Whether you're talking about internet protocols with communications, you're talking about grabbing data from instruments like we're doing here. Generally, you're going to see headers applied to whatever raw data that you grab. Like, for example, here's our square wave, and these are all points. But also, we showed that there is a header. Every time we grab this set of points, there is a header attached to the front end of these points. And in our case, it's called a TMC header, which gives you an encoded value explaining how many points are in this case, each waveform that we're grabbing. And you can see here down in this text box, we're showing that this has 1,200 data points that we grabbed each time. What we're doing here is we are updating this, and we're going to show you in future video how to update this, in our case every 0.2 of a second, to keep grabbing data. But what we did previously when we grabbed the data is we said, well, we kind of know how many data points are going to be in each grab of the waveform. And what we did is we just stripped off that data, that TMC header, which comprises the first 11 bytes of data in this packet of data describing the waveform. So we just erased those first 11 bytes and grabbed the data and plotted it. Now what we're going to do in this video is we are going to look a little bit deeper into that TMC header and find out what it is and how we can decode it. And this is really important, like I say, for any electrical, electronics, communications, data gathering project, because you're going to see this a lot and you're going to need to use these a lot. And in our case, it can be very useful in the future to find out, hey, are we grabbing a very low number of bytes, or are we grabbing hundreds of thousands of bytes? And the amount of bytes we grab determines how we're going to handle the data. So it's really important. So we're going to look in this video into what that TMC header is, how is it laid out, and how can we decode it and use it in our application. So now, as we mentioned before, what we're doing when we're programming our oscilloscope is we are looking at the, in our case we have a DS1024Z by Rigol oscilloscope, and we're looking at their programming guide that we showed before. And in the waveform section, where we capture waveform data using this Skippy command, we showed that there is a description in this document of the TMC header, which is down here. So first of all, what is TMC? Well, that is Test and Measurement Class, which describes the class of instrument. So it says the format of the TMC data description header is £n with 9 numbers, where pound is the denoter, n is the number 9, and then the 9 data values or bytes following that denote the number of bytes of the waveform data. So this basically, these X's are numbers that are telling us, if we decode them, how many bytes will be following every time we do this waveform data request, right? Waveform data, which says, hey, send us all of the data for the waveform on whatever channel we're accessing. So let's go into Excel and take a look at a visual description of what we have. Here on the top is what we might see in a TMC header coming from our scope. So when we do a waveform data request, we will get the first 11 bytes might look something like this with these numbers. And then following it is the actual data bytes. Somehow we have to take these numbers and figure out what do they mean. The document says it describes how many bytes are going to be in this package of data bytes, but these numbers don't look like a really good description of how many bytes. Well, it turns out these numbers are decimal bytes. They are decimal numbers. And each decimal number is the decimal equivalent of an ASCII character. This 35 is an ASCII character, this 57, this 48, and so on. So how do we figure out what are the equivalent ASCII characters? Well, here on, if you go to ASCII-code.com, you can see up here, there is a table showing the decimal values, the octal, the hex, the binary, and then the ASCII symbol, right? So what we can do is we can use this to decode what those decimal characters are. So for example, if our header says the first number is 35, we can go into this ASCII table and go down to what is 35, and you can see down here 35 is the ASCII symbol, which is a pound. And as we showed in the programming document, the format of the TMC data description is pound, n, and then a bunch of numbers. So yes, the first number or the first character is an ASCII pound. If we look at our header, we get a 57, and if we go down to 57, that is a 9, and n equals 9. So now we've got the pound and 9, and the next one are the data describing how many bytes. What we can do is say we got a bunch of 48s. So what's 48? Well, we can go back up here. Here is 48. That is a 0. Aha, so we've got 0, 0, 0, 0, 0. What's 49? Well, 49 is a 1. So we've got a bunch of zeros, then we got a 1, and then we got a 50. And you can imagine if 49 is 1, then 50 is 2. So we got 1, 2, and 48 is 0. So we've got 1, 2, 0, 0. So this is telling us that there are 1,200 bytes of data following in this packet of data. Very interesting, when we grab from the screen in the mode we're in, we're going to get 1,200 bytes. Now that varies depending on what mode we're in the scope. In some modes, you can get hundreds of thousands of bytes to describe the waveform you see on the screen. So once we've got that, how do we know how to convert these numbers in our code into ASCII characters? Well, what I've done is I've added a method called numBytes from TMC. So what we pass it is a list of bytes, which is the bytes of the waveform, the entire list of bytes from the waveform, and this will extract the TMC header and tell us how many bytes and return a double. So here is the code we're going to use. So we're starting out saying that the length of bytes for the TMC is 11, the first 11 bytes from the waveform bytes. We're going to define a character array, which is a new character array that will be the results after we convert these from decimal bytes into ASCII. We'll have a character array of length 11 TMC char array, which will give us these ASCII characters, the #900. We're going to then send to our read text box TMC, we're going to print out what the results are. And then now what we're going to do is we have a for loop from 0 to 11, in our case, the TMC length. And we're going to take each waveform byte, those decimal numbers, and convert to char. We're using the convert to char method to take the decimal byte numbers and convert them to characters. And the TMC char array will give us an array of the actual ASCII characters. And here what we're doing, we're taking the first 11 TMC decimal bytes and sending it to our text box. And then here we are converting that TMC char array to a string. And that will give us a string of what's the actual TMC ASCII characters that will tell us what the number of bytes is. And here what we can do is we take that string and convert to double. And what we're doing is we're taking the substring. We're getting rid of the first two characters, which is the #9 characters. We're doing a substring, which gives us everything after the first two characters, the #9, which is the actual number of bytes. So we're taking that substring, converting to double, and that will give us the number of TMC bytes. So now we can look at our application, and here is the actual raw TMC byte characters, and here is the result after we have parsed it. So now you can see how we can take that TMC header and parse it with our code and get some useful information. We're going to use that in the future when we have variable data lengths depending on the mode we're in, and we can use this to more exactly figure out how many bytes are in our array of points from the scope. So that's about it for this one. In the next one, we're going to talk about doing some testing, because when you're grabbing data from devices, it's really important that you understand how long it takes to do a request and then grab the data. So we're going to dig in a little deeper to how to figure out what's the turnaround time, what's the time between you send a request and you actually get data, so that we know how fast to set our system timer for our request. We don't want to send it too fast because the equipment might not be ready to respond and we'll get a bunch of junk. So we're going to look a little bit deeper into the timing of our equipment. So that's about it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Otherwise, take care. Have a really good day. Thanks.